In the quiet dawn of a new wireless era, the world stands on the edge of a transformation, the rise of 6G. What begins as early pre-commercial experiments worth barely $500 million to $1 billion in 2026 is poised to expand into a thriving ecosystem valued at $150 to $300 billion annually by 2036. It's not just a leap in speed or bandwidth, it's a decade-long revolution reshaping telecommunications infrastructure, devices, applications, and business models across the planet. At the core of this evolving market lie four powerful segments, each with its own rhythm of growth. First, the infrastructure, base stations, core networks, and edge platforms, forms the foundation of 6G's vast digital architecture. Then come the devices and terminals, from next-generation smartphones to IoT sensors, vehicles, and industrial systems, connecting everything everywhere. Beneath them, the beating heart, semiconductors and components, where GaN and InP power amplifiers, advanced transceivers, and ultra-low power processors bring 6G's vision to life. And finally, the services and applications, the human side of the network, unlocking holographic calls, digital twins, autonomous coordination, and deeply immersive extended reality. Behind this evolution lies a symphony of technological convergence. The sub-terahertz spectrum, 100 to 300 GHz, opens unimaginable bandwidths, enabling data speeds that blur the line between physical and digital. But these frequencies demand radically new RF architectures, a challenge and an opportunity for innovators. Artificial intelligence becomes the silent conductor of this network, orchestrating autonomous optimization and predictive resource allocation with machine precision. Meanwhile, reconfigurable intelligent surfaces, RIS, reshape connectivity philosophy itself, extending coverage at a fraction of traditional costs. And soaring above, non-terrestrial networks knit together constellations of LEO satellites, HAPS, and drones, delivering universal coverage to over 3 billion unconnected people. Yet, even revolutions face resistance. The 6G dream encounters obstacles, spectrum allocation complexities, immature sub-THz technologies, uncertain business cases, and geopolitical fragmentation that threatens to split standards between East and West. For success, the path forward demands unity, affordable technologies, global harmonization, and applications that offer true leaps beyond 5G. Only then will operators justify massive investments, not by cannibalizing old revenue streams, but by creating entirely new ones. The Global 6G Market 2026 to 2036 report stands as a monumental 400-plus page analysis, a roadmap through this unfolding transformation. It's a guide for telecom operators, semiconductor pioneers, materials scientists, and investors seeking to navigate a market worth hundreds of billions. From sub-THz semiconductors to zero-energy IoT, from non-terrestrial networks to autonomous systems, the report dissects every layer of this vast ecosystem. As 5G deployments near completion, the spotlight shifts, sharply, towards 6G's revolutionary potential. Imagine data speeds of 100 gigabits per second to 1 terabit per second, latency measured in microseconds, and networks connecting 10 million devices per square kilometer. It's not science fiction, it's the blueprint of a hyper-connected planet, uniting terrestrial and satellite systems into one seamless web. But to reach that future, engineers must overcome formidable challenges. At sub-THz frequencies, power amplifiers struggle with efficiency, while thermal loads exceed 5 to 10 W per square centimeter, demanding advanced cooling and material innovations. Packaging antennas at 100 to 300 GHz poses engineering puzzles that stretch the limits of today's manufacturing. Spectrum allocation, too, remains a moving target, a chessboard of global negotiations delaying deployment. To meet these challenges, the report evaluates 25-plus semiconductor technologies, from GAN and INP to SIG BIC MOS, benchmarking each against 6G's demanding standards. It identifies where breakthroughs are essential and where evolutionary improvements will suffice. At the materials frontier, more than 50 advanced compounds enter the stage. Low-loss dielectrics like Rogers and PTFE, thermal solutions like diamond substrates and graphene heat spreaders, and exotic newcomers like ionobles and vanadium dioxide, all shape the hardware of the 6G age. Each material is evaluated for performance, cost trajectory, readiness, and supply chain strength, offering an unprecedented map of industrial potential. Emerging 6G architectures take form: ultra-massive MIMO arrays with thousands of antenna elements, cell-free networks dissolving boundaries, and RIS panels cutting infrastructure costs by up to 80%. Zero-energy IoT devices harvest power from ambient signals, ending the era of disposable batteries. Every model, every simulation, every economic scenario is meticulously mapped: urban, suburban, and rural. Across regions, the global race intensifies. Asia-Pacific leads with early launches projected between 2030 and 2031, followed by North America, 2031-2032, and Europe, 2032-2033. United States flag European Union. Each nation's strategy, from funding levels to industry collaborations, defines its place in the coming 6G landscape. High above Earth, non-terrestrial networks expand humanity's digital reach. From Starlink and OneWeb to Kuiper and emerging Chinese constellations, thousands of satellites weave a planetary web of connectivity. These systems face immense technical and economic tests, launch costs, link budgets, and global spectrum coordination. Yet they may hold the key to connecting everyone, everywhere. In the grand arc of innovation, from 1G's first analog calls to 6G's intelligent, holographic, and universal web, humanity's communication story continues. The next decade will not merely connect devices, it will connect realities, industries, and imaginations. And as 6G rises, so does the promise of a world where information truly flows at the speed of thought. And so, as the world stands on the threshold of the 6G revolution, one truth becomes clear: the future of connection isn't just faster, it's smarter, seamless, and profoundly human.